Have you ever had a brilliant idea for an app and just wondered, how does that actually get made? How does it go from being just a thought in your head to a real thing you can use? Well, it's definitely not magic. It's a process. It's a blueprint, really, that guides creators from that first spark of an idea to a complex working system.
So yeah, that's the big question, right? How does a simple idea become that powerful app that you literally use every single day? The answer, it turns out, is all about understanding how to build a system, one logical step at a time.
To get a handle on this, let's use a simple analogy. Picture this. You've got a box filled with robot parts. On the one hand, you've just got this disconnected pile of metal and wires. Kind of useless, right? But when you connect them in exactly the right way, they become something totally new, a functioning robot that can actually do something. And that right there is the heart of what a system is. It's not just a bunch of random stuff thrown together. It's a group of components that are all interconnected, all interacting with each other to achieve one specific goal. Just like our robot.
And at its absolute core, every system, doesn't matter if it's a coffee maker or a global banking network, it all boils down to this simple three-step logic. It takes something in, that's the input. It does something with it, that's the process. And then it produces a result, that's the output. Simple as that. That's the foundation for everything.
Okay, so if we want to build our own system, we're going to need a plan, some instructions. And in the world of technology, that master blueprint has a name, the System Development Lifecycle, or just SDLC for short. Think of it as the game plan that brings order and predictability to what can be a really chaotic creative process.
The SDLC basically guides us through a six-step journey. First, we figure out what we actually need. Then we design it, we code it, we test the heck out of it, we launch it for the world to see, and finally, we keep it running smoothly. We're going to walk through this exact path right now. So, first things first, the requirements phase. Before a single line of code gets written, we have to know what we're building and, just as important, why we're building it. Going back to our robot, we'd have to ask, what's its job? Should it be welding cars on an assembly line, exploring Mars, or maybe just making a decent cup of coffee? You've got to define its purpose with crystal clarity.
So how do you figure all that out? Well, developers basically become detectives. They might go and observe how people are currently doing a task. They'll interview the folks who will actually use the system. They might send out questionnaires to get a ton of feedback, or even build a really simple prototype, like a basic clickable model, just to see how people react to it.
All right, so once we know what we want to build, it's finally time to, build it. And, just as crucially, we need to make sure it doesn't immediately fall apart. This phase is all about construction and quality control. It all kicks off with the code. This is where developers take all those plans and blueprints and start translating them into a language the computer can actually understand. Little by little, that abstract idea starts to become a real, tangible thing you can interact with. And that brings us to a really critical question. Just because you've screwed all the robot parts together, how do you know it's actually going to walk? How do you know that shiny new app won't crash the second somebody tries to log in? Well, the answer is you have to test it, and I mean thoroughly.
The testing process starts small, with something called unit testing. This is like checking every single part of our robot individually. Does the elbow joint move like it's supposed to? Is this one specific sensor giving an accurate reading? You test every tiny component in total isolation to make sure it does its one job perfectly.
Okay, so all the individual parts work on their own. Great. But can they play nicely together? That's where integration testing comes in. Now we start connecting those pieces that we know work. Does the arm actually respond when the sensor sends a signal? It's all about making sure the parts can cooperate and work like a team.
Finally, it's time to zoom out and look at the big picture. First, there's system testing. This checks if the fully assembled robot actually achieves its main goal, like can it successfully navigate a room and make that coffee? And then there's user acceptance testing, or UAT. This is the ultimate test. You hand the controls over to the person who asked for it, and you ask them, hey, does this do what you needed it to do? Their yes is the final green light.
So with a fully built and brutally tested system in hand, it is time for the really exciting part, deployment. This is the moment of truth, when we finally release our creation out into the wild and let it start doing its job for real.
But how exactly do you launch something new? Well, you could go for what's called a direct deployment. This is the rip the Band-Aid off approach. You turn the old system off and you turn the new one on. It's definitely high risk, but it's fast.
On the other hand, you could use a parallel deployment, where you run both the old and the new systems at the same time for a while. This is way safer because you have a backup, but it's also more expensive and a lot more complex to manage. There are also some more cautious ways to do it. A pilot deployment is where you launch in just one department, or maybe one location first. This lets you work out all the kinks in a safe, controlled environment. Then there's a phased deployment, where you roll out the new system gradually, one feature at a time, slowly replacing the old system piece by piece.
And that brings us to the final step, which really shows that the journey isn't over just because you've launched. The last phase is maintenance. I mean, think about it. Just like a car, a software system needs regular tune-ups, bug fixes, and upgrades to keep up with new security threats and changing user needs. This is a step that keeps the system useful and valuable for years to come.
So we've got this 6-step blueprint, the SDLC. But does every project follow this exact same path every single time? Oh, not at all. You got to think of the SDLC as more of a framework, not a rigid law. Teams actually pick a specific model that really fits with their project needs. Let's look at a couple of classic approaches.
First up, we have the famous waterfall model. You can see it's a very strict, linear path. You absolutely must complete one phase, like getting all the requirements, before you can even think about starting the next one, like the design. It's perfect for projects where the end goal is crystal clear from day one and it's not going to change. But there's a big risk. If you're way down the line and you discover a mistake from an early step, oof, it can be incredibly hard and super expensive to go all the way back up the waterfall to fix it.
And then, in complete contrast to that, you have the iterative model. Instead of trying to build the entire thing all at once, you build and improve the system in these repeated cycles, or iterations. So you might build a basic version with just the most important features, release it, get feedback from real users, and then use that feedback to go back and build the next, better version. This is fantastic for projects where you don't know everything up front. You learn and adapt as you go. It's super flexible, but it can be harder to set a final deadline and budget.
So here's the big takeaway. The SDLC is so much more than just a process for programmers. It's a really powerful way of thinking. It's a method for taking on any complex project, whether it's software or something else entirely, and breaking it down into manageable steps to turn an idea into a reality. And that makes you wonder, doesn't it? What's a complex problem in your own work or even your own life that you could solve with a clear, step-by-step blueprint like this?